good evening, everyone. I am audible, right?
Yes.
Okay, yeah, thanks. In this today's session, we will go through some of the introduction of this unconventional machining process. Then we will be discussing ultrasonic pressure jet machining as well as this water jet machining and combination of these two. So some of the books I can refer is this one, Manufacturing Survey Science by Ghosh and Malik. You might know as well. The other one is the Advanced Machining Process, which is a dedicated one uh, by VK Jain. Okay, then let us start. So you might have already attended these classes earlier, few weeks back, in which the tutor covered some of the ECM and EDM topics. So I'll just go through some of the introduction, then I will go to the actual part of the today's topic. So one is the non-machining process. The basic difference are also known as non-traditional machining or unconventional machining process. So one main thing is there is no direct contact between this tool and workpiece. Some medium will be there in between the tool and workpiece. For example, in ultrasonic machining, you can see there will be slurry with abrasive particles. Suppose if you take any this electrical processes such as EDM or ECM, there will be in ECM there will be some electrolyte, and in EDM there will be some dielectric present. So there will be no direct contact in these processes, and there are different forms of energy we used. Unlike in traditional processing, we entirely depend on the shear deformation of the workpiece material. But here we use so many other energy sources such as this
Sir,
heat source. Yeah, yeah, yeah.
your voice is reflecting, sir.
Is it same for everyone?
No, sir. No, sir.
Okay, yeah, thanks. Okay, so so that is the main differences you can say between these non-conventional and conventional processes. So now we come to the need why we go for non-conventional process if there are conventional processes already available for performing an entire job. So one is if there is any difficult to cut materials. So this is a fancy word, difficult to cut materials. So we classify any material into this category if there is very while cuttings in conventional process. Suppose if you're turning a workpiece, suppose say you have very high tool wear rate, so the tool is getting worn out very easily. That is one. The other one is it is a ductile material, so it is very difficult to cut. You'll get a continuous type of chips. That is other two. The other one is it has low thermal conductivity, so the buildup of this heat in the material will be very high. So the entire energy that you are producing will not you know exactly useful. So there are some like this. There are two, three, four reasons to classify any material into difficult to cut materials. Okay. So the other one is to generate complex shapes and surfaces, which is difficult in conventional process. And the other thing is the accuracy, surface finish, as well as the product difficult to geometry, to produce a difficult geometries with ease. Okay, so let us move to the next. So here I'm showing some of the uh, processes. So one is the ultrasonic machining, the other one is electrochemical machining, abrasive jet machining. So in this the setup for abrasive jet machining are water jet machining or abrasive water jet machining. So all these three, the setup looks similar. Just the medium. Suppose in abrasive jet, we are just forcing these particles with mix, which are mixed with air. Suppose in water jet machining, we are just the medium. The medium is changing. That's it. Water or abrasive combined with the abrasive and waters. So these are three different process. which are having three different applications. Then finally the EDM process, in which we use an electric material. So there will be a buildup of energy and one instantaneous drop in energy, which will instantly evaporate the workpiece surfaces. So these are the different types of process. So this is the general classification, you can say, based upon the energy that we are using. So let us come from the left side. So the first one is the mechanical type of energy that we are using, which is abrasive water jet machining, or ultrasonic machining. In this, we use mechanical type of energy. So then comes to the electrochemical. Uh, so that is the electrochemical grinding or electrochemical machining. Okay. So don't be confused with this grinding. We just replacing the tool with the rotary tool, so that actually the mechanical also comes to add in this place. But the main reason for material removal is this uh, removing of material due to this electrochemical process. Then come to the other process, thermal processes, that is laser beam, electron beam, ion beam, electric discharge machining, or the plasma machining. Then finally, chemical machining process, chemical machining process or photochemical machining.
Sir,
Yeah, yeah.
in water jet, only water cuts the material.
Yes, yes. The water comes with very high velocity within a narrow region, so it has enough power to cut.
Okay.
Okay. So now the main important for this gate exam or any competitive exam will be the finding this material remove rate, material remove rate in all these processes. So we have to concentrate on what is the material remove rate in each process. So now I hope you can see this. I think you can see now a little bit. So this was the direct image I have taken from the book I mentioned, that is Manufacturing Science by Goshen Malik. If you have this book, or the soft copy is available in it, or you can buy one. It's a very good book to keep it with you. So so these are the mechanics of material remote rate. They have mentioned for each process. And also I suggest you to prepare one of your own. Like you can write material removal rate, and you can write the process, and you can write how the material removal rate is changing with respect to tool rate and everything. So once you read everything, you can make a small chart, like compendium of all these things. So these are the different types of material removal rates. So I will be discussing in the further slides also. So let us start with this ultrasonic machining. So so the main thing is this ultrasonic vibration, the frequency that we use, that is around from 19 or 20 to 25 kilohertz frequency we use, with an amplitude of 10 to 15 microns. So we have a slurry which is mix of generally we use benzene and some abrasives. Okay, this is the type of slurry that we use, or we can use as a water also. Then so there are so many parameters that we can play with. So one parameter is this, we can do the mixing ratio, that is the water. Suppose if I'm taking water to this abrasive ratios. The other one is the size of abrasive. I can also call this mixing ratio as concentration. Okay, then I can play with the amplitude, that is a, I'm denoting small a, that is the amplitude. So these are the some of the parameters that I can play with, so in order to get the desired surface finish, or desired tolerance that I need in this any type of works. So the basic principle is that, so when this, so this is the horn, or the concentrator we call, and we have for this ultrasonic frequency generating from some transducer. So This transducer can be piezoelectric, magnetostrictive, uh, I think the spelling is wrong, but magnetostrictive or piezoelectric. And one more thing is there. But these are the two main transducers that we use for generating, for getting this frequency, ultrasonic frequency. And this will be connected directly to this horn or the concentrator, and it will concentrate all this frequency towards the tool. So this is the tool we are using, and this tool what it does, so these are the abrasive particles. So it will just, first of all, the first process happens is that the force of the tool will be transferred to the abrasive particles. Okay, AP I'm writing abrasive particles. So first that impact will get to these particles, and these particles will later will travel and hit the work. Okay, these are the two processes that will be happening in this process. I think this is clearly intuitive also. Then when this happens, there will be some small crack forming on the surface of the workpiece, and in the progressive steps this crack will propagate and will get, this surface get removed, and this happens to enter the surface. Sorry. So this is the principle of operating this ultrasonic machining. So now I have said some of the parameters. I will tell you how. So the main aim of everything is MRR, material removal rate. So all these parameters will affect this MRR. So we have to remember how this affect this MRR. So there might be a question so with respect to MRR. So if you change the mixing ratio, so what happens to MRR? How the graph looks, or if I change the amplitude, or if I change the concentration, or like these parameters, we should know how this behavior, what is this behavior happening here. So that I will be discussing later. So this is the main principle of working, and so I should tell what is the MRR here, mechanism of MRR. So the mechanism of MRR in this is, so as I said, there will be a crack initiation followed by brittle failure. So it should be concentrating on this brittle failure or brittle fracture. Okay. Okay. So I have written on the left top crack initiation or the brittle failure or the mechanism of this. This is the main significant material removal rate. There are insignificant mechanisms also. One is, so when this abrasive particle hit the surface, there will be small amount of material will be removed before forming this crack. That is one, and the other is this abrasive particle will get eroded with the workpiece. Sorry, this workpiece. So it will be removing some material due to fluffing away, some other effects. So these are insignificant mechanisms. So this is the main mechanism. So you should remember this. You should remember this brittle with respect to these abrasives. So wherever you use abrasives, so the main mechanism of removal is through brittle. So you should remember these two words simultaneously. So that's it about ultrasonic machining. So let us discuss some of the advantages and other things. So it is independent of hardness as well as this conduction. So some of the materials may not be conductive, so that we can use in this type of process like ultrasonic, abrasive water. All this process does not depend on the workpiece electrical properties or thermal properties. So we can easily use it. Then can we use any class of material, but limited, we generally use this for brittle materials. The reason being the mechanism of removal rate. Suppose if you use any ductile material, so these particles will not remove. Instead, these particles will protrude into the workpiece surface. So I missed one more thing here about this tool. So Can you remember what type of material should be used for this tool?
Tungsten carbide
Okay. Why you use tungsten carbide?
because of high hardness and उस तरीके से.
But if I use hardness because of high hardness, would it be the tool wear ratio? Tool wear will be higher, right? Because of brittle failure of the tool also.
Yes, sir. Yes, sir. So soft
So
tool you
any
will use.
yes. We have to use soft tool in order to reduce this tool wear. So generally we use copper as the tool material in this ultrasonic machining. So these two you should remember.
Sir.
Yeah.
But that abrasive particle will get embedded in the soft tool.
Yes, of course. But it is not removing the. It will be embedded in the tool, and this tool get work hardened. So that is beneficial to us. So the tool wear will be less, right?
Yes, sir. And can you scroll down, sir?
Yeah.
Here, machining is independent of hardness of workpiece, but it is dependent on workpiece hardness.
So don't be confused with this two hardness and so brittle type of materials. It of course
Yes.
it is the resistance on the surface itself.
And brittle means throughout means its body.
Yes, throughout the material. For example, combining these two things, I can say glass. Okay, but yeah, glass is the best example I can right away give for you. So don't be stick with this hardness. Stick with the material, complete material, brittle.
Okay, sir.
Okay, yeah. Then comes to these are the some of the advantages. Uh, so then come to the limitations. So one thing, so this you have to remember low tool wear rate compared to the other machining process such as EDM as well as ECM process. You might know the burst formation in conventional machining process. Here we don't have any such type of burst. Then
Sir,
so these are the some of the yeah.
Sir, here is highest, sir.
Ultrasonic machining.
Y- Yeah, yeah, sir. Then EDM and ECM.
Yes, correct. In terms of material removal rate,
Sir,
that is
MRR is low, but tool wear is high
yes.
in USM.
you are we having a layer formation, right?
In here.
Yes, sir, I am asking.
So mainly we are not concerned about this layer formation here, but this phenomena, so we call this layer as recast layer, is very much important in EDM process. Okay, here we'll not bother about that, that layer formation.
Okay, sir. Sir, in MRR, what are the points to remember? Like,
In MRR,
what are the points to remember? You told, sir. Can you please repeat this?
just one is the workpiece should be brittle, the tool should be ductile. Generally, we use copper, you can remember. And the mechanism of material removal rate is this brittle failure. These are the three important things you have to remember in ESM. That's it. So, so the questions will be not asking directly, but they can ask you the application type. Suppose if I want to machine glass surface, what type of machining is preferable? So, okay, you should think in that way also. If there is any failure due to brittle fracture, then it should be ultrasonic machining. If there is option in the if there is option ultrasonic machining, you should take it. If there is no USM, but if there is abrasive jet machining, you should go for abrasive jet machining, because in abrasive jet machining also the phenomena is same. MRR mechanism is same. Okay. So these are the some of the limitations. So these limitations comes comparatively with the conventional process. Okay, this expensive hyper consumption, low material rate, so heat affected zone always complex mechanism of the material removal, difficult to control the process, highly skilled operators. Okay, sorry, this heat affected zone is not correct point here. So that, but the other are applicable to this ultrasonic machining. And here also you don't have to worry about this option. Okay. uh, then comes to the applications. So as I discussed, these are the some of the examples. I don't think gate they will ask directly these things, but in other competitive exams they might ask you, they might give this material and they might ask you what type of machining process you use. So you should better remember. So one of the common thing in all these things is this brittleness. So in that way you can remember all this type of materials. So precious stones are marbles. Marbles you can cut with water jet also. This glass is very highlighted here, so generally we go for glass. And then there are two pros and cons. So typically it has a low material removal rate. So this is comparing, I'm comparing with the conventional process. And the tool wear rapidly, machining area and depth are limited. So one more thing is this. So in this setup, uh, if I want to change, so you might have also familiar with this any forming examples. So the die is very costly, so we have to uh, think about redesigning anytime. So here also similarly, if you want to change, so this tool is not exactly like this, but there will be some impressions on it. So if you want to change the tool, you have to change the complete setup, and this frequent changes can cause inefficiency, errors, and
Sir, your voice.
yeah. Yeah, hello.
Yes, sir.
Hello.
Sir, now
Yeah, yeah. Okay. So, so when you come to this cons and pros, so in pros, this is precise machining of brittle medicine happens. Tiny house does not produce. So this is the main thing you have to remember. This does not produce any electrical, thermal, or chemical damage because it removes the metal mechanically. So this is one thing you have to remember. So this is useful because of this. This is the main reason that we go for ultrasonic machine. If there is, if your workpiece is sensitive to all these things, then you should do go for only ultrasonic machine, because in other, like any electrical type of process, these things might get affected for the workpiece. So we'll have a quick quiz on whatever we discussed.
So
Then we
those
can proceed
cons,
with the. Sorry.
so the cons which you mentioned above, it's with respect to conventional machining.
Yes. Yes.
Oh, okay, sir.
Yeah. These are some of the questions. You can just go away, give a quick quiz on this.
First Ace.
Okay. Yeah. Let others also think. Take it 1 minute time. So in my clock it is 7:36. Answer at 7:37. I will ask. Okay. Just think all the questions.
sir, can it be multiple option correct?
We'll discuss. If you have multiple, just stay with. We'll discuss. Yeah, we can discuss the answers now. So first one is copper. Second one is
Still,
Fourth, steel.
okay. Third one
Yes.
is
Third one will be first.
okay. Actually, I have not discussed. I will discuss.
Fourth is
Fourth
third.
one is
Mechanical.
mechanic.
nice. So if you see previous year questions, so most of the questions on ultrasonic machine will cover only these topics. Okay. So now, if so, I have so if at all they can ask any there is no numerical till now. If they can ask any numerical, they have to ask in this way. So for deriving MRR also we have certain big derivation, but you don't have to go through that derivation. If they want to ask, they have to give the MRR formula for you. So there is no need. So before going to those problems, I will discuss some of the relations. Okay, just give me a minute. Yeah. So first thing, so now I'm discussing the effect of these parameters on the MRR in ultrasonic machining. So this is ultrasonic machining. We are discussing MRR with different parameters. So the first parameter is MRR with frequency. Okay, I will give. So if they want to ask, they can, they can plot different types of graphs.
Fourth one.
Which one is one? Fourth one.
D.
You know why? Is there any reason?
Yes sir. The reason is that मतलब कि if the frequency exceeds some मतलब critical point के बाद क्या होगा कि जो उनको relaxation time जो होगा सर वो मैच नहीं हो
Uh,
पाएगा सर.
mm, any other students? Which one is correct and what is the reason? So the correct one is this thing. And if you see the slope, it is increasing, and it is increasing fast. Initially, then decreasing. Okay. So initially fast increase, then later it is a slow decrease. So MRR will keep on increasing. So there will be no decrease in this. So we are playing between 20 to 25 kilohertz frequency. So if you have more frequency, so the moment transfer to these particles is more. So which is related to this MRR. So the if the particles are getting more moment, they will hit the workpiece more, and they will remove the material more. So there is no point like there will be relaxation. So we are increasing MRR, we are not decreasing it. So there is always increase in MRR with increase in frequency. And I will discuss the formulas, the MRR formula, which is derived, in which we will get the like correlation like this, the frequency correlation with some exponent. Okay. So let me here discuss the other factor here itself. Amplitude. So what happens in this case? A, B, C, D. Increase, decrease, linear increase.
No, sir. Amplitude would be decreased, sir.
Amplitude will be increasing, but the slope will be decreasing.
Correct. So there is a so the curve will be just opposite of this. It will be like this. Okay, slow increase in okay, there is a slow increase in the slope initially. Okay, so this is the behavior with respect to amplitude. If we increase the amplitude, this is the type of graph we get. Because if there is higher amplitude, there will be more time for the abrasive to get accelerate and collide with the workpiece. So which in which case the MRR will go up. Okay, so there are some other parameters also. Abrasive size. Which graph do you think with respect to abrasive size? A, B, C, D.
See,
Any reason why it continuously increases?
because as the size of particle increases, it will impact on more larger surface.
Okay. See, suppose so. This is the gap. You can see the screen, right? This is the gap. Okay. What if I take a abrasive particle of this size? Will there be any moment transfer? Momentum transfer?
It will jam.
It will jump. So there will be no MRR. That will just vibrates, but there is no momentum transfer. It will just move with very slow velocity. There will be no MRR at all. But initially, as you said, there is a limit to which this impact will increase. Initially, with the smaller size or bigger size, so there will be a limit crossing which the MRR will decrease. So in which case, option D will be the correct one. Initially, it will increase, and then it will decrease. Okay. So this is due to this moment transfer for the uh, these abrasive particles. If the size, I discussed this amplitude factor, right? If the size of the abrasive equal to this amplitude, then there will be no moment transfer to the particle, and there will be no MRR at all. So it will directly declining. So if you see and the amplitude I am talking about, so if this is the frequency that, so this is the total time period of interaction. So this is the amplitude that I am talking. Okay, and in this amplitude also, only for small amount it will contact the workpiece. So this tau, whatever I have written, that is the only the time in which this tool contacts the means hits the grid, hits the abrasive particles. If the abrasive particles is itself this A, then there will be no transfer in momentums. That's why after certain critical value, this MRR will decrease. Similar trend we
Sir,
can
but
observe.
in amplitude graph, it is shown that MRR continuously increases.
Where are you saying MRR increasing?
MRR versus amplitude graph.
Yes. But I have fixed the size of the abrasive na here. Abrasive size is fixed. I'm just increasing the amplitude, but the size of the abrasive is fixed. But here I'm not changing the amplitude. It is for only one amplitude, but I'm changing the abrasive sizes.
Yes,
Okay.
sir.
You then MRR with percentage of abrasives are the mixing ratios or the concentration that I'm talking. So what is the reason of this behavior? Here I'm changing the percentage of abrasives.
So क्रॉस ग्रेन कोलिजन विल बी द मोस्ट मतलब कुछ समय के बाद इम्पोर्टेंट फैक्टर हो जाएगा.
हाँ. So we can call it as mutual collision. There will be a collision between particles itself. So the momentum will get lost in that process. So after certain limit, there will be a drop in MRR. Then comes MRR with respect to viscosity. Can you guess what is this? Why, with respect to viscosity, why it is decreasing?
Less moment transfers of the abrasive particle.
Why? Why?
Due to viscosity,
I
abrasive particle will slow down.
Okay. You have studied fluid mechanics. So what happens? What happens if I increase the viscosity to any object traveling? What is that term called?
It means more drag.
Yeah, yeah. So this drag will. So there will be a competition between drag and momentum. So when you increase this viscosity, this drag will dominate this momentum transfer. So hence the MRI will come down because the abrasive particles will get less amount of momentum, which hits the workpiece. The reasons you said is the other student said is correct. The viscosity will slow down, but this is the main reason, na? Drag or momentum. So these are the some of the parameters that can play with the MRR, how it is changing. So you can simply get a question, if at all you can get a question like this, the question between how MRR versus percentage of concentration, and they can give all this ABCD and you should select. So you can think what is the reason, what would be the reason, then only you can take this answer. Okay, don't go direct away, don't need to remember, also just remember these concepts. Okay, with respect to frequency it will increase but fast increase. With respect to amplitude it will increase but the slow increase. That is the reason the curve is in this way. With respect to abrasive size, you can remember the amplitude. If abrasive, I have explained, if the abrasive size is too big, you cannot remove material, so there will be a critical value. Similarly, for the percentage abrasive, there will be a critical value, and of course viscosity is easier to remember. Okay, and these are the different types of parameters that can play with MRR. So let's move. I will discuss one of the question at the end. Let me cover this also. So in
Sir,
abrasive jet, yeah, yeah.
in case of amplitude, there is no limitation, means because it is showing increase.
Yes, yes, there is no limitation, but it will be the limitation with respect to the design aspects. You cannot design infinite amplitude of tool. Okay, there will be
Yes, sir.
limitation for the design factor. So there will be certain range for amplitude also. So let me discuss abrasive jet machining, all these three. So the medium in abrasive will be air and this abrasive particles. Water jet machining, it is only the water, and this is the combination of these two. So we mix air and water together. So in abrasive jet machining, we are using abrasive particles. So there will be a brittle failure for the workpiece. In water jet machining, there will be micro cutting or micro cutting or erosion, you can say. In abrasive jet machining, it depends on what type of material you're using. Suppose if I use ductile materials, there will be plastic failure. Suppose if I use brittle, there will be brittle failure. Okay, and this is the mechanism as well. Okay, and the rest is similar. In abrasive jet machining, we mix these abrasive and air particles and we pass through the nozzle. So this nozzle should have very high wear rate. So we use sapphire or tungsten carbide or what the materials which are having very high abrasion resistance, you can say. In water jet machining, we use this type of intensifiers. So in which we'll get very high pressurized water, and the which is allowed through nozzles. So this high pressurized water, when hits the surface, it will slowly erode the surface and it will pass through. In abrasive jet machining, we are just combining these two effects. Okay. This is the basic principles. I will talk more in later. So similarly, I will just abrasive jet machining for the sake of understanding, and you can make out for others also. Similarly, I'm playing so MRR versus different types of factors. So actually, there is no question on this aspect. If you are finding it difficult, you can leave also. With the abrasive size, percentage of concentration. Then one more thing comes in this type of machining is standoff distance, MRR. Sorry. Standoff distance, but accuracy. Okay. Let me draw the curves. Okay. With increase in abrasive size, the MRR will increase in this case. Whereas in ultrasonic machining, it will increase, reach a critical value, then decrease. But here it is continuous flow of these abrasive particles. So there is no case of jamming in this case. So we will get continuous increase. And then with the standoff, then we discuss the second one. With the percentage of concentration, it will increase initially, then it will decrease. So can you guess what is the reason here?
Same cross grain collision.
Let's moment.
Yes, less moment transfer in case of this with respect to percentage of concentration. So what happens in case of standoff distance?
Not able to attain a specific momentum required for brittle failure.
Okay.
इस वजह से रिड्यूस करता है ये कारण.
Okay. So I just discussed this concept of drag and as well as moment, right? So if I increase standoff gap, what happens? Which will dominate here?
Material remove rate.
No. See, in this region, since I'm getting increase in momentum, increase in MRR, sorry. So momentum is higher. It is dominating the drag. So drag happens in this case also. And you are using air here, okay, instead of the slurry we used in that case. But here they are more or less equal. But in this area, this drag will influence, so that the particles that are coming out, they cannot, after traveling certain distance. So certain distance, say this value, point C, says point B and point A. When it travels this much distance, there will be so much drag that it has less amount of movement. So it will have less movement, so it will not effectively remove the material. So that is what happens in case of standoff distance. This drag will overpower the momentum if you increase the standoff distance. Understood?
Yes.
Then comes the accuracy with respect to standoff distance. Of course, the accuracy will decrease standoff distance. So the effect generally people call as
Diverging.
yes. It is mushroom effect. So if you see the machining process, so it will come and it will form some mushroom kind of things, which looks like a mushroom. Okay. So due to this mushroom effect or diverging effect, I can say, So the accuracy of this machining part will decrease. So if I want to cut only this much, now I am getting bigger cut initially, but further I am getting this much only. Okay, so in that case I am losing some of the accuracy. Okay,
Yes,
so I will hash the, this is the required, the hashed with the blue is actually what I want, but instead I'm getting the other things. And this is the rectangular hyperbola. Okay, then, so these are the sum of applications. So I have given you only with respect to abrasive jet machining. So these are the two main operations that are important. So others are not that many important. So I just gave only two types of, means the parameters affect in only these two process. So now come to the applications. We use for low strength materials such as wood, plastic, rubber, paper, leather, etc. These applications I have combined all these things. So water jet machining we can use for cutting this you know frozen meat or any marbles, as I said, which are a little brittle kind of things. Whereas this abrasive jet material also for brittle materials. This is composites. So all these things are
Sir,
okay, but yeah,
what is it? Frozen?
frozen meat. This is meat
Okay, sir.
in food industries. These are mainly used for this type of
And marble
materials.
means that stone.
Yes. And this abrasive jet machining is mainly used in cutting. Abrasive jet machining mainly used for composites. So you might see this polymer composites, right? Epoxy, glass fibers, which are essentially used in aerospace materials. So we use this composite, this AWJM for this, especially for these composite materials, because these are all these types of materials are not conductive, so I cannot really go with the other types like iridium kind. I cannot go with it, or I cannot go with conventional machining because of the some of the difficulties that I have discussed earlier. Then food preparation, I have given the example there. Okay, which cannot withstand high temperatures of other metals for stress distortion and medical reasons. The best example for this third option is the composite, in which the operating range is very less. 150 degrees, I can say that epoxy can withstand to some 300 degrees Celsius, not more than this. Then comes to the pros and cons. No need for pre-drilled holes, no heat, no workpiece deflection, minimal environmental friendly. This environmental friendly applies only to water jet machining. Okay, not for the abrasive water jet machining. This environmental friendly applications applicable only for water jet machining. So there are some environmental concerns when you use abrasive jet machining. So if there is, so generally these operations are done in a closed chambers. If there is any leakage, it will these abrasive particles are so small, it will combine with the air, and if any operator inhales those things, he will get damage in these health problems, you can say. Similarly, disposing of these particles, these abrasive water jet machining, disposing of this slurry or whatever that I get after machining is also a challenging task. So these are not eco-friendly, environmental friendly. But water jet machining is environmental friendly. I can just keep a filter and reuse the water. So limited to metal with naturally occurring small cracks. So this applies to abrasive water jet machining as well as abrasive jet machining. Softer materials applies to water jet machining. Okay, and I will give these mechanisms. Just a second. I have discussed earlier already. So here, so for water jet machining also, erosion is, so there are so many kinds of actually the material removal mechanisms in this process, like water jet and abrasive water jet machining. So one thing, so some of the significant would be depending on the material you use. So we generally have two types of materials: brittle or ductile materials. So in brittle materials, you might already understood there will be a crack initiation, followed by the crack propagation, and finally a brittle failure will occur. So, but whereas in ductile materials, we'll have a initially we have a fluffing effect, then followed by small micro cutting, then plastic failure. So these materials are will not yield easily, whereas brittle materials yield easily. So there is easy removal rate. But in ductile they will not yield. They will instead they will what they will do. They will elongate whatever the material, small material that I'm using. They try to elongate in any, that is like plastic deformation happens. So it has to fail with respect to plastic failure. So this mechanism in MRR in these are little complex, but this is what you can gain from this. It depends on whatever material you're using. Okay, so this is about the theory part. Now let us discuss some of the problems. So I will give a minute for all these type of questions. Then I will attempt. Let us start with ultrasonic machining. So if at all I'm asking any questions, so there are no questions till now. If I'm at all I'm asking any question, I have to. They will specify MRR for you, so you don't need to worry. You just have to put the values. So the notation also will be given in the question itself. If you have any doubt with the notation, you can ask me. Yeah, you can look at this question once.
Is the answer 4 mm cube per minute?
Okay, let us wait. If you have done this fluid mechanics course, it will be straightforward question.
Sir, can you show the graph that you draw the MRR with respect to diameter?
No, that is not needed. I have given you the formula itself.
Yes sir, formula is given. I want to see. मुझे याद आ रहा है कि आपने डाउनवर्ड भी दिखाया था उसमें, मतलब स्ट्रेट लाइन
Okay.
नहीं था. MRR versus diameter. सर आपने यहाँ पर रिड्यूसिंग दिखाया है एब्रेसिव साइज के साथ, पर उसमें डायरेक्टली प्रोपोर्शनल है सर।
Okay.
सो सर स्ट्रेट लाइन होगा ना?
No, no, no. So this was the correct one. So basically, this ultrasonic. Sorry, this question right? Yes. So basically, this ultrasonic machining has different derivations. So one of them MRR I have given here. No, I think earlier one.
2 pages above.
Is one such derivation, and there I'm not quite sure, but this DC maybe there are some elements, say some area or any other factors in which DC is combined in this. Is like suppose A is function of DC is something like that. Okay, it is not direct proportional.
Okay sir.
Okay, and we did not take any effect of all these parameters. Even if you assume small, I think this might be the correct one, but the graph is correct. Initially it will increase, then it will decrease. So one answer I got 4 MQ per minute.
Sir, 4.
Area is also function of D here.
No, I am not quite sure, but
ये
some factor,
amplitude
yeah, some
Sorry,
factor,
answer
some
is 4
parameters.
in
Yeah, tell me.
answer is 4 then.
Yes.
Answer is 4.
Yeah. So if it is
So what you are talking about area?
no. So there was one graph, if you remember, the graph is like this. But according to this formula, it should be a linear proportional. So what I want to convey is, so there might be some other factor, other parameters, CF, A naught, A, any parameter that might be a function of DC are indirectly affecting it, so that the graph is changing into non-linear. We didn't really go through derivation, so we cannot come direct conclusion. Okay. This is correct graph that I have given. This size and MRR. So let me solve this. Okay. So this is how, following this question, there is some addition. You can just read this part.
zero 0.3% increase.
No.
So almost no change.
Give me the
Exactly.
value of MRR.
Like 6.02.
Yeah. So I
Yeah.
should give the old MR. Uh, I did not give the old MRR. So MRR old is 6. You can just find what is this MRR you are getting.
Yeah, sir. 6.0186.
Okay. Yeah. So it is just C nu by C volt with the exponent of 1 by 4. F nu by F volt, the exponent by 3 by 4. I think I have given right here. So if you put, so what did you observe? There is no change, right? 6.02. Even with increase in 50%, but there is a reduction in 70%.
But the
Okay, they're just asking you what is the effect if I increase this and decrease the concentration. Okay. So coming to this question, yeah, I think so. I have just referred the book. So yeah, I think this is true. So it is in linear only.
Sir,
Linear in the
Yeah. Okay.
how that is related to fluid mechanics? Previous problem.
Yeah. Nice question. So generally, this is actually 3 questions. So initially, this where is it? The velocity. Okay. Yeah, just hold a minute. I think that is not the one. I think this is related to fluid mechanics. Okay, just have a look. Yeah, sorry for that. This question is related to fluids.
Hello, sir. From which book you have taken this question? On this?
These questions are from the. So I forgot to mention that there is one NPTEL course, like Introduction of Non-Unconventional Machining Process. So there, these are the some of the the transcripts they have given. So these are some of numericals you can solve. But I have converted into, so in that those intended for normal academic kind of curriculum. So if at all if we want to convert this into gate, I little modified these questions. So these are from this NPTEL old NPTEL assignments, you can say, not assignments. So there are transcripts you can download.
Okay.
But you don't need to read all those things. Just concentrate on what exactly you need. I just framed these questions keeping in mind this gate exam. It should not take much time. Did anyone got the answer?
Sir, I am not getting what.
So So, what is mass flow rate of water when they have given water pressure of 400 bar being issued from our phase, diameter is given, velocity is given. They are asking you what is the mass flow rate, assuming all related questions to be, I think 1.
6319.
So 0.063 kg per second.
0.0363
63.
kg per second. Okay, yeah, maybe. So you know this discharge formula into V, that is
Into CV 0.929 कितना होता है सर CV?
CV. Here I said take 1. Okay.
बट एक्चुअली orifice में 0.92 होता है.
I'm not quite sure right now about the values. Maybe I'm not sure. Then we have this mass flow rate. Just multiply with the density. Whatever you get in kg per second or kg per minute, whatever. You'll get mass flow rate. This is I'm not giving it can be. This is volume flow. This is volume discharge, right? Q. So
Multiplied by 1000.
yes, yeah. So 0.3. What is this? 894. Yeah, understood. I just multiplied with the density. This whatever discharge or volume flow rate you have.
Yes.
So this is the continuation. You have to determine this depth of penetration, that is HT. I have given here. I think all other parameters you have. So if you see this type of questions, you can just, so there are questions like this. You can just use this, and you should be sure about the units that you are using. So I need this in mm. If you're concerning, this is pressure. Okay, here it is given here.
So here pressure to be put in bars itself.
No,
In
either you
megapascal.
have to follow. No, if you see the units, you'll get to know easily.
Yes, sir, it will be megapascal.
Are you sure?
Yes, sir. Newton by mm square, na?
Mm-hmm. You should keep everything in this formula in MKS units, you can say. So I'll come one by one. So this will be in meters. This has no units. So this pressure will be in Newton per meter square. This will be in joule per mm cube. You have to convert it into meter cube. So you'll get a factor of 10 power 9. Then this should be in meters, and this also should be in meter per second, and this should be in kg per meter cube.
Sir, then it will be, will it be mm if everything is in meter cube?
Yeah, I just wrote it here mm. I just asked you like depth of penetration in mm. I need in mm, but in this formula, if you do, you will get in meters only.
Okay.
Because it is MK system. No? Yeah, sorry. One small modification. Just note this 3.8 is 1 by r, not r. Sorry for that. Just note this one small correction. This 300 mm per minute.
Sir, is the answer 20 mm? 20.45?
Okay, let us see. 20.4 mm. Just wait for others also. The answer given in this is 77.6 mm.
Sir, I am getting 32.32.
Okay. 32 mm. So just so the answer given in this thing
Yes.
is 77.6 mm. Just check whether you are getting this value or not. So you can stop. You can try it later. It is just a substitution. 77.6 the answer. You can note it down. You can try. So if you observe one thing, so in these type of questions, everything is simple, but it consumes times. It consumes time. So be clear with it. If you're attempting, it will take time. So either you do at the end, or so it depends upon your strategy you are following. In 2019, there is a question in which you have to find the stress in a rolling process. So everything is given, but the only thing is you have to put every value in it, but it consumes time. That's it. So in that, keeping that in mind, I framed this type of questions. Okay. Yeah, that's all for today, and all the best for the exams. And you make this, as I told in the starting, you make a formula sheet for all these type of non-conventional machining or any type of other subjects also. Just refer it before going to exam, so it would help you. So in this type of problems, if there is big formulas for the like this MRR or in any rolling process, if there is any big formulas that you cannot remember if there is small formulas, not the big formulas, they will be given in the exam. So no need to remember these formulas or any such these kind of formulas. Okay, thanks for attending.
Sir,
If there is
other
any
than
next
this
one, please.
method, ECM medium.
These are already covered by one of the tutor in the previous weeks, so that's why I didn't cover those two. I was informed by NPTEL to modify my this presentation. Accordingly, I covered only these three. ECM and EDM are covered earlier. Anyone attended those
In phase
classes?
1.
Uh, Earlier, some other like me has taken. I think some 3 weeks back, you can say.
Yes, sir.
But they are directly straightforward numericals. So if you want to practice, so this is the reference you can go. You can practice previous year examples and you can take the reference. You should be just careful with the units only.
Sir,
In
is
There are
that
one
numericals.
process,
exam also
MRR is minimum easily rememberable?
Yes, yes. You need to remember the formulas for this. They are
For
simple
ECM
side for.
and DDM.
Yes, yes. You have to remember.
Other than these four methods,
Yeah, these are
any
the
more study?
mainly important. So others is like you can just read the theoretical type of. They might ask theoretical questions. Even in this type also, most of the questions are theoretical. Only ECM and EDM are the numerical type questions. So whatever other processes, you just have a understanding of the working principles and its MRR, mechanism of material removal rate. And it's if there is any particular application, you can remember it. Otherwise, you can just remember mechanism as well as the process.
ECM and DDM must be prepared well.
Yeah, you should prepare well. There are numerical questions on that.
The unconventional machining process, part one was taken by whom?
Uh, just give you a minute, I will check.
Vijay, you said it was covered, right?
I am not sure, but in the slot is made in the website.
Okay.
I think this Ashdeep, some tutor is there, right? He's covering this air conditioning psychometry. Actually, he initially filled the slot for this unconventional. So that is the reason I cannot cover the other one. Otherwise, I would have started with those only. Okay. So you know this tutor Ashdeep who
Yes,
covered
sir.
this air
He
We
conditioning psychometry. Yeah, actually he filled the slot. Like we have to fill the slot in advance. So he filled the slot for unconventional process, EDM and ECM specially. So that's why I covered the other one. It is also available in. Okay, it is not available in that NPTEL Gate website.
he took thermodynamics and thermal subjects. UCRS, I mean,
If you see uh, in this Gate portal, so on week 6, 26 December to 1st Jan, so on Sunday 7 to 8 p.m. So non-traditional machining process,
yes, sir.
ECM and EDM.
I think
Yes,
it was
yes.
changed to thermo. Someone messaged in the chat box.
Okay, it was slot changed to 6 and 7, January 3rd. It was written here. So that's the reason I cannot cover those. So that class was not taken?
Taken, sir, but for that RAC
Okay,
part.
he has taken RAC. Okay.
Sir might be
Requested
taking
just
that
for
after
Okay, okay. Okay, maybe he's
psychometric.
planning to cover in future. I don't know. So when is this exam?
February
Fourth
4th.
pay.
For I think you better revise the things. You better stop learning new things right now. But you should prepare this ECM and EDM very well.
Okay, sir.
So if you want any material, so if you see this NPTEL lecture, that is Introduction to Non-Conventional Process.
So professor name?
Just a second, I'm just seeing. I think Chattopadhyay, Professor A.P. Chattopadhyay, IT Kharagpur.
Okay.
So he has there. You will get these transcripts, or you can just go to this manufacturing science by Goshen Malik. So this is the best difference you can go. Or if you want to dwell more, this advanced machining proposed by VK Jain. If you want to solve problems, just go to this. If you want really go in depth knowledge, you have to go for this VK Jain book, Advanced Machining Process by VK Jain.
Sir, that ebook available?
Sorry,
Whether
can you repeat?
ebook available for that?
Yeah, yeah. I cannot say it directly, but ebooks are available for these two. Can easily get.
No, actually, I want just ECM numericals.
You can buy a book, or you can get this book ebook. Then you can just go to the topic. Okay.
So please upload the any shortcut notes if available on the drive links from your subjects.
See, one strong suggestion I can give: you should not follow other chart sheet. You should make it on your own, if it takes times. Okay, that is the way you remember the formulas. You should revise every morning those formulas. Okay, if you want, if you have any like thing like if I miss something, so in that case, so this was one book like handbook by this Medici book. You can buy that one. So in which everything is covered. So one more thing is that is the main book, handbook kind, small book you will get for all the subjects. But I cannot say 100% it covers everything. So limitations will be there for any book. So better prepare by yourself.
Sir,
Yeah.
if possible, can you means, upload that ECM numericals on Drive?
Drive. Okay. Okay. Just a second.